Algebra 2, Part 2. This is the fourth day of parabolas, so it's our second day of determining if a parabola is wider or narrower than y equals x squared, finding our x-intercepts and finding our y-intercepts. So we'll be doing the same thing that we did yesterday. We'll just be practicing it on a few different parabolas. So I'll go over really quickly what we're doing and how we do it. To determine if a parabola is wider or narrower than y equals x squared, we're going to have to look at our a value. So if the absolute value of your a value is greater than 1, then you're going to be narrower than y equals x squared. If you're less than 1, then you'll be wider than y equals x squared. And of course, if a equals 1, then the parabola will be the same width as y equals x squared. And how we find the x-intercepts, well, it's the same thing as taking our quadratic equation, setting it equal to 0, and solving it. So you can do this a number of different ways. You can use the quadratic formula, which will work all the time. If you see some easy factors, you can go ahead and factor it and solve each set of factors, kind of like we did at the end of Chapter 5 and the beginning of Chapter 8. Or you could solve it by completing the square, or by taking square roots if it's set up that way. Okay, so to find the x-intercepts, you're just setting the whole thing equal to 0 and then solving for x. And then if you're curious about how many x-intercepts you should end up with at the end of the problem, you can take a look at your discriminant, which is b squared minus 4ac. And so this table kind of gives us a breakdown of how we can use the discriminant to figure out how many x-intercepts we'll have. So if your discriminant is positive, then you'll have 2 x-intercepts. If it's negative, you'll have 0 x-intercepts, and if it's 0, well, then you'll just have 1 x-intercept. And that x-intercept will also be the vertex of the parabola, and it will be on the x-axis. So that's kind of a neat relationship, and a lot of things that work out if you have all of that situation in play. So how do we find the y-intercepts of a parabola? That's probably the easiest thing to do. Your y-intercept, if your equation is in standard form, your y-intercept is just going to be c, right, or your constant term. And if you don't see a constant term or you don't have one, then your y-intercept will just be 0. If your equation looks like something else, then you can just plug in 0 for x and simplify. Okay, so we'll go through these classwork problems. Finding the x-intercept is usually what takes the most work. So we'll start each one of these by finding the x-intercept. Okay, so for number 1, to find that x-intercept, I'm going to set that equal to 0. So I'll have 2x squared minus 5x minus 3 is 0. Now, I'm going to guess that this is something I can factor. So I'm going to try to factor this with first and last. I'll have a 2x, an x, and the whole thing is 0. I'm going to do minus 3 plus 1. So that'll give me negative 6 plus 1 is negative 5. So that works out. So then I'll split up my factors, set them each equal to 0, and solve. So 2x plus 1 equals 0. I'll go ahead, minus 1, 2x is negative 1, divide by 2, x is negative 1/2. So that's 1 x-intercept, and then we can add 3, and x is 3. Okay, and then so we can go ahead and start giving our answer. Well, the parabola is going to be narrower than y equals x squared because your a term is 2. The x-intercepts are going to be negative 1/2 and 3. And then your y-intercept, well, remember you get your y-intercept from plugging 0 in for x, or it's just your c term, right? So then in this case, we can see it right here. It's going to be negative 3. So we can say y is negative 3. All right, so those are all our answers for number 1. Let's go on to number 2. So we have y is 2x squared minus 8x plus 5. So I can go ahead and set this equal to 0 and try to factor it. So let's see. I'll have a 2x minus an x minus, let's see, 5 times 2 is 10. So let's see, let's do 5 and 1. I don't know if this is going to factor. So So that'll give me -5, -2 is -7. Or if I switch those up, we get, let's see, let's make this a 5, and oops, and that a 1. So that's -10, -1. Nope, that doesn't work either. Okay, so this does not factor. So we're going to go ahead and try the quadratic formula. All right, so I'll plug these values into my quadratic formula. So I'll have, let's see, x is -8 plus or minus the square root of b squared. So -8 squared minus 4 times 2 times 5 all over 2a, so all over 2 times 2. So if we simplify this, we get a +8 plus or minus the square root of 64. Now, let's see. We'll have a minus, and then 4 times 2 is 8 times 5 is 40. And then that's all over 4. So that will simplify again. We'll have 8 plus or minus the square root of, well, 64 minus 40 is going to be 14, okay? And 14 is just 2 times 7. There's nothing inside of that that we can pull out. So, and because 2 and 7, you can't take the square root of either of those. So for this particular problem, that is as far as you can go for your x-intercepts. What we could do is plug these into our calculator to get a decimal approximation. So let's see, I'll do 8 plus radical 14 and then divide that by 4, and I'll get, let's see, one possibility is 2.95 or 2.9. Let's see, let's just do 2 decimal places. 2.94, and then the other possibility, we'll do 8 minus root 14, and then divide that by 4, and we get 1.06. All right, so those are your two x-intercepts. So giving our answers here, well, y is 2x squared, so your x term is 2, which is greater than a. So for part A, we'll say the answer is narrower. For part B, our x-intercepts are going to be 2.94 and 1.06. And then for part C, our y-intercept is going to be 5. Okay, so that's it for number 2. We found all of the pieces. So that was a good example of one that doesn't factor, but you can find the x-intercepts if you run through the quadratic formula. Let's go on to number 3. So we'll go ahead and start off by trying to find our x-intercepts. So we'll take the function negative 2x squared minus 2 and set it equal to 0, and we'll try to solve this. So the first thing I could do is factor out a -2. And so if I factor out a -2, I'll be left with x squared plus 1 is 0. And I can go ahead and divide both sides by -2, and I get x squared plus 1 is 0. And if I try to solve this, x squared is -1, and then if I try to take the square root of both, I get x is positive or negative I. So that's an imaginary number. So we don't have any x-intercepts for this particular problem. Whenever you try to solve for your x-intercept and you get an imaginary number, that means you have no x-intercepts. All right, so we'll go ahead and write out our answers. So wider or narrower, I think we will be narrower, right? Because our a term is -2, and the absolute value of that is greater than 1. Our x-intercepts, in this case, we said we didn't have any because when we tried to find them, we got an imaginary answer. And then for part C, our y-intercept, Well, remember, to find your y-intercept, you're going to plug 0 in for x. So let's see, that looks like negative 2 times 0 squared minus 2. So that's just going to turn into a negative 2. Okay, so your y-intercept for number 3 is negative 2. So that's it for number 3. Let's go on to number 4. So first off, we'll try to find these x-intercepts. So we'll take the function, set it equal to 0, okay? So we'll try to solve this, divide by 3, x squared. Well, anytime you have 0 divided by a number, it's just going to be 0. So then in this case, if I were to take the square root of everything, our x-intercept is just going to be 0, okay? So then the rest of the problem is pretty easy for here. So pretty easy from here. So for part A, y is 3x squared. Well, your a value of 3 is greater than 1. So in this case, we'll say that we are narrower. Your x-intercepts are going to be just 0. And then for part C, your y-intercept, remember you get your y-intercept from plugging 0 in for x. So for this case, we'll just get 0, okay? So not very exciting at this point. We have narrower, 0, and 0 for our intercepts. So let's go on to number 5. All right, so for number 5, we have this function, and we'll start off by setting it equal to 0 and trying to find our x-intercepts. So to go about starting to solve this, we can add 4 to both sides. Ultimately, what we want to do here is get the x, is solve for x, get x by itself. Right, so then I have 4, and then I can divide both sides by negative 3. So then I have x minus 2, the whole thing squared, is negative 4/3. Okay, so now I have the x minus 2 squared by itself. So what I could do here is take the square root of both sides. Now, I kind of hit a wall on the right side. If I take a square root of negative 4/3, that means I'm taking the square root of a negative, which you can't do. So that would be an imaginary number, right, when you take that square root of negative 4/3. So in this case, we would say we have no x-intercepts. All right, so we'll go ahead and answer the other questions. So for part A, we want to know if we're wider or narrower than y equals x squared. Well, remember, we look at our a term, which is sitting in front of the vertex form. That's negative 3. So in this case, we will be narrower than y equals x squared. And I got it from that number, negative 3. For part B, we want to know if there are any x-intercepts, and we can say none. And then for part C, we want to know the y-intercept. Well, we can get that y-intercept just by plugging in 0 for x. Let's see. So we'll plug in 0 for x to get the y-intercept. So what that looks like, okay, we'll have negative 3 and then negative 2, the whole thing squared, minus 4. So that'll turn into negative 3 times 4 minus 4. So that's going to turn into negative 12 minus 4, which is negative 16. So then our y-intercept is negative 16. All right. So that's it for the classwork today. So hopefully that clears anything up, and you can go ahead and try tonight's homework assignment.